Monday, everybody.
Monday.
We've got a couple things today. So the lab I want to go over, that was our rock, paper, scissors, lizard, Spock. We had project 1 that was due, and then we have new stuff. So hopefully the first hour or so we can knock out the lab and the project, and we'll take a break. We'll pick up the new stuff. It actually opened automatically because I did it early for someone who was leaving. They wanted to work ahead. So if you want to sit quietly and work on it, ignore me. That's perfectly fine. You're not going to hurt my feelings. But the lab and next project should be open. I'll go over those at the end after we've talked about the new stuff. For anybody who is following along, usually it makes more sense after we've heard some of the stuff. So first, let's do the lab. Is that rock, paper, scissors, lizard, Spock? It's kind of fun. And I think if you got it in, I scored it for you already. I checked on that before I left home. So just building on rock, paper, scissors, we're adding in lizard and Spock. So each item loses to 2 items and wins against 2 other items. We'll ask the user what they want to throw, randomly generate the throw for the computer, tell them win, lose, or draw. Now, many of you went up way above and beyond, and I was impressed that you checked every single win condition and gave me the correct sentence, like Spock or paper disproves Spock, or rock crushes lizard. I was just expecting you to say win, lose, or draw because that's easy. And that's what I'm going to do if you don't mind, because that's the easy way out. If you did above and beyond, that's fantastic. You had more practice using these conditionals, so no big problem there. This was lab 2. So I'm going to start a new project. I'm going to do this in the main repository for the course, not in the new repository that gets created, right? So I'm not going to make this repository, clone it, and copy it, because I want to be able to have you see this code if you want it. It'll be in that repository. This will be for lab 2. And we should be in good shape. Get this started up here. All right. So we're going to ask the user what they wanted to do, right? So we'll get the, the user's throw is going to be an input of, pick or enter, rock, paper, scissors, lizard, or Spock. Hey, Professor Burp, thanks for joining online. And then we'll pick a throw for the user, or the computer. So we're going to have to do something random, so we should import random, random here. Then the computer's throw, we can pick a number. 1 to 5 is probably easiest, like 1 being rock, 2 being paper, 3 being scissors, 4 being lizard, 5 being Spock. Sure. Well, I mean, any sort of random number you want to generate is fine there. So we'll have the computer. This will be, if we do a number, we can then assign it to a string, right? Or if we wanted to, it might actually be easier here. You might tell the user, hey, let's enter 1 for rock, 2 for paper, 3 for scissors, and on and on and on, right? Going this sort of way. 4 for lizard, and then we bump this down a line here because it's getting long. Or 5 for Spock. And then I can have the computer be a number and the user be a number, and I can compare 2 numbers. That generally works out relatively well here. Probably a little easier than comparing the strings. I'll show you both ways if you're curious, but numbers are going to be easier for us. So the computer throw could just be random.rand int 1 to 5, right? 1, 2, 3, 4, or 5. Those 5 that we talked about. Now, if I want to compare numerically, I need to make sure this is also an integer, right? Because by default, our inputs are strings, so we're going to convert. So I'll say, hey, I want this to be an int of an input here. Now I can compare 2 numeric values. Under indented? Okay, all right, it got quiet when I tabbed it in a little further, so that's happy. So, right, the win condition, the lose condition, and the draw condition, if we're playing the game, you can either win, lose, or draw. So some of you went through and looked at every single possible way to win, every single possible way to lose, and then how to draw. And I'll say, I'm going to be lazy, and I'll say, hey, this is how you win, this is how you draw, and if you didn't win and you didn't draw, you had to lose. So we'll leave that as just an else here. So I can say, hey, if the user's throw, we don't have any parentheses here, sorry. If the user's throw is equal to the computer throw, we can just print tie. If it's not a tie, right, else if, now we have a bunch of conditions, right? And I've said let's do the win conditions, because I like that. So, and I don't actually remember what beats what, so let me Google that real quick. Rock, paper, scissors, lizard, Spock, again, here. And look this up and see who beats who. Okay, So lizard will eat the paper and poison Spock. I don't know. Let's start with one. So let's look at, how about if the user's rock? So we'll say, okay, if the user's throw is equal to 1, that's being rock. Now, having the numbers in here is a little bit ugly, so it might be nice here then. We could say, hey, rock equals 1, paper equals 2, making these sort of like constant values here, just so I have a nice name instead of a number. It's not required, but it's going to make this look a little cleaner here, because that way our code won't just have numbers. It won't be like 1 and 3 and 1 and 4, and trying to remember what a 1 and 3 are. Here, so we'll have rock, paper, scissors is a 3. We'll have lizard is a 4. And we'll have Spock is a 5. Spock equals a 5. So if the user's throw equals rock, and the computer's throw is equal to, so rock will beat scissors, right? Scissors. So that's one way to win, right? And I'm going to put this in parentheses. So technically ands happen before ors, but I'm just going to be more clean here. So we'll say if this one, or if the user's throw is equal to rock and the computer's throw is equal to, so rock also beats lizard. Lizard, right? That's another possible way to win. We can say, or, nope, not or, I think we need our slashes here, right? There we go. Tell Python we're going down another line. So that's the two ways to win with rock. Let's look at paper. So if the user's throw is paper, I'm just going to copy paste this in here. If the user's throw is paper, or the user's throw is paper, well, paper will beat rock, and paper also beats Spock, if I remember right. Like, it disproves Spock, I think is the saying there. So two ways to win is paper. Or two ways to win as scissors. So if the user's throw is scissors, and then so scissors will beat paper, and scissors will decapitate lizard, right? Is that scissors decapitates lizard? Okay, that's a way to win. So I've done rock, I've done paper, I've done scissors. Now, the other ways to win, we could have the user could be lizard. So if the user is lizard, then lizard will beat, I have to go look this one up again, lizard will beat Spock, and lizard will beat paper. Okay, lizard beats paper, sure, lizard beats Spock. Done. Or, last two ways to win here. I'm not going to need that last or. If the user is Spock, and the computer is, well, that's the wrong one, this one. Spock smashes scissors, and Spock vaporizes rock. So scissors and rock, okay, sure. Scissors, there we go, or rock. Colon. Right, all of that is one big if else if. Now it's a little ugly right now, but if you go to code, you can go to reformat code or Control-Alt-L, and it will line everything up for you nicely. Right, don't bother trying to tab the stuff yourself. Just Control-Alt-L will format it for you. We'll do it pretty nice here. So if any one of these is true, right, because we're ORing these together, all of these are ands. So both these need to be true, or both these need to be true, or both these need to be true, or going all the way down, right? This is the dollar menu. If you want anything on the dollar menu, you say yes, right? Otherwise, you keep on driving because we don't have enough money for gas and fast food that's not on the dollar menu anymore, right? So we'll print player wins, or you win. I don't know, you win. How about you win? You wins? No, you win. And then, if you didn't tie and you didn't win, we just have an else. You lose, right? We don't need to check all of the other conditions where the computer wins or the conditions where we lose, because we know if we didn't tie and we didn't win, we had to lose. Now, some people went through and made each one of these be an else if. That's perfectly fine. And then if you did each of these as an else if, you could then go and say, okay, well, rock smashes scissors, rock crushes lizard, paper covers rock, paper disproves Spock, scissors cuts paper, scissors decapitates lizard. You could like do a custom statement in each one of these. Sure, it's no problem here. The lose statements would be tricky at that point. We'd have to sort of essentially copy the same thing but flipped for the computer to see what they're going to do for winning. So I like this. It's easy, and that's all we really needed to do for the assignment here was just win, lose, or draw. I did that one on purpose. I didn't want, I mean, if you did the extra work, great. It's probably prettier that way, but this will at least tell us win, lose, or draw. And if you wanted to, you can even say, hey, this is what the computer threw. Now, to do that, though, we'd have to go and say, okay, if it's a 1, let's print computer's rock. If it's a 2, computer's paper. there's not really a great way to convert back and forth between these here. So again, we're sort of taking some shortcuts. We're not telling the user what the computer was, right? If we wanted to, that's fine. Or if we wanted to deal with strings, right, we could say, okay, if the user's throw is rock and the computer's throw is scissors, we could do numbers here. You know, lots of different options here, however we go about this. I like using the numerics because input is easy. They only have to type in a number, right? You want to make things easy for your user, 1, 2, 3, 4, or 5, rather than typing stuff in. And I'll be honest, when I ask my kids to play, if they have to type in scissors and spell it right, you know, the 14-year-old, the 13-year-old, the 12-year-old will probably get it, but my 10-year-old and 7-year-old, there's no chance they're going to spell scissors right. I mean, even with it being right on the screen here, they're going to say scissor and like not even look up at it. So make things easy. All right. Any questions, thoughts, concerns on this one? Right, just lots of practice using ifs and ands, right, and ors, if else ifs, right? Tons of different ways we could have done this, right? This is not the only solution for sure. Okay. Awesome. All right, so I'll go ahead and commit that here. That's 2131. There we go. So here is lab 2. I don't need that one, I don't think. It's fine. We'll just, I don't know, sure. If anything in that idea folder changes, just let it change. It's no big deal. PyCharm likes to keep all sorts of stuff around. All right, let's talk about project 1. Let me start another project for that. Project 1, this was our fence helper, right? This one had a little bit to it here. I like this one because there's a lot of logic that kind of has to go into it. It's not just, let's take the perimeter divided by the length of our board, right? That doesn't work because if I have a 10 by 10 fence, right, and I have posts every 5 feet, so I have a post, and a post for one side, and a post, and a post, and a post for the other side, and post, post, post down the side. If I buy a 9-foot board, the most I can cover is one set of posts, right? I can take 5 foot of that board, put it between 2 posts. The other 4 foot is just scrap, right? It was dumb of me to buy a 9-foot board, but maybe that's what's on sale, was on sale at Home Depot, right? That 4 foot goes away. So I'm going to need 8 sections of board, right? 2 for each side to get 2 5-foot sections to go all the way around, right? 2 for this side, 2 for this side, 2 for this side, 2 for this side to go all the way around. So you can't just say, hey, the perimeter is 40. Let's do 40 divided by 9. Well, okay, it must be 45. We're going to need 5 boards. Doesn't work like that. You need 8 boards. So you have to figure out the amounts of posts you can cover with your boards. Okay? So that was for... All right, so one of the things we've talked about is doing the same thing over and over and over again is really tedious, right? We looked at that when we were doing, what was that number? Collat's conjecture from like 2 weeks ago, if you can remember back before Memorial Day, where if you take a number, multiply, if it's odd, multiply by 3 and add 1. If it's even, divide it in half, and eventually you always get back to 1. So far, it's been unproven, but we had to like copy paste a bunch, and I felt really bad about it. That wasn't great. And the general rule of thumb is if you have the same code twice in your program, you should feel bad about yourself. Just a rule of thumb. You don't actually have to feel bad about yourself, but ideally you only have the code in there once, and then you can just ask it to do that same code again. And that's what we're going to talk about today, is how I can get repeating this block of code as many times as I want. So one of the things we did is like print out some info and ask for some inputs and do some sort of things here. Now, ours weren't super interesting here, but we did some check for an integer. Right? We said, hey, give me an int of an input here. So we would say, was it the length was an int of an input, enter the length, and a width is int of an input, enter the width. Okay. Typing this out here is not too bad. It's not the worst thing in the world, but we could make a shortcut for ourselves. So essentially what a function is, it's a block of code that we're putting a name to. So I can write a function that does anything I want it to do and then call it by name. So one of the great things about functions is we can put names to what's happening in our code. So this one's not the most interesting example here, but I can write my own function. So I can say define, or def for define, and we'll say this is, I don't know, get an integer input, to get an integer input here. Now, I don't know what message to give it though. So what I need here is I need to be able to give it a message. So when I use this function, just like when we say input and we give it a string here, we're telling the input function, here's the thing you're supposed to print, ask the user to type something in and give it back to me. And a couple things are happening. So we can have a prompt. We can say, hey, I'll give you a prompt when I call this function. You can use this prompt. So what happens when you call this function, we now have a variable named prompt that has some sort of value. Right? So I can say, I can print the prompt if I want. Here, it'll print out the prompt. Or really, you know, int of an input here. So we'll have our value is an int of an input given that prompt. So now I'll have a value that the user entered. If the function needs to give you something back, there's a special keyword called return. So return is the keyword to give a value back to whoever called your function. So input gives us something back that we can assign. Right? Int gives us back something we can assign. Math.ceal gives us back something we can assign. But if I were to say with print here, if I were to have some result is print test, 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 and then I were to print out result here to see what it was, just give this a run real quick. Sure, length, width. You get this funny none thing. When it prints result, there is nothing returned. Nothing was given back here. So if you just return and you don't return anything, you're getting back a none. So if you're familiar with other languages, none is a null. There's no value here. It just doesn't exist. So we just can't do anything with it. So that's okay. So you can have functions that return values, or you can have functions that don't return values. That's okay. Print doesn't return anything. So print return any values. But like int and input, return values. So you can assign them to something. So in our case, we're going to return the value. We say, okay, I'll use the prompt. You give me the prompt. I'll use it in the input, turn it into an integer, save it as value, and we'll return the value. Sure. So now instead of these int of inputs here, I can just use my name here. Notice these are kind of show up in that kind of reserved blue. That blue means it's a Python reserved word. It means something special in the Python language already. But I can just use my function here, get integer input instead, and get a value back. Why is it unhappy? It wants 2 spaces. There we go. Is that better? So my function that we just wrote, we told Python, hey, I'm going to make something called get integer input. If you use the word get integer input, all it's going to do when it runs is jump up to here and run this code. So far, when we have run our code, it goes to the first line, to the second line, to the third line, to the fourth line, to the fifth line, and then maybe this if there's an if, maybe this if it's an else, but it just goes line by line by line by line. Now what we get to do with these functions is we tell it, hey, go back and do this. So if I were to put a breakpoint here and run it in debug mode, we can actually watch it jump, which is super cool. So we'll see it's ready to go. There's nothing here. Now, before we'd use step over when we were debugging. Sorry, it's really small. I don't have a good way to zoom this in. But instead of stepping over, we want to make sure we step into. And there's 2 step intos. There's a step into and step into my code. The step into my code is a better option because things like the int or inputs here, you can step into Python library code and it's going to be super confusing. And we probably don't care. Like it does what it's supposed to do. So I'm going to step into my code and I'll see I started at line 7, right? I'm in the main file here. File's name is main. I'm at line 7. So this main py:7 says you're at line 7. And if I step into, notice it stays here at line 7. And then it adds this. This is known as the call stack. So Python knows when this function is done, go back here to line 7 and keep on going. So it's going to track all this stuff here, which is really fun. So now we have a value for prompt. So we'll see prompt here is a string and it's enter the length. So you can see the value of that variable. Sorry, I don't think that one, that one doesn't zoom, which is really annoying. But you can see what the value of prompt is. And then we'll step. Now, nothing's happening here in the debugger, but it's waiting here at the console for us to enter something. So enter length 10, And then we get back in debugger here. Now we're at line 3, ready to go. So we'll return the value. We see value is an integer value of 10. So I can step, and I get back to line 7. And when we step, now length now has a value of 10. This function returned something, and we assigned it to length. So all we did is essentially jump up to here, run this block of code, and then come back to where we left off. We'll do it again, and again, and again, and we step. Yep, and now we're waiting at the console, enter a width here. Sure, that's 10. I can see length and width, and I can step, and finish. Oh yeah, we printed test, test, test. Oh, we never went down. Okay, that's a little ugly. We never went down a line, but that's okay. Not too big of a deal. It's not the prettiest output. So we put a name to what we're doing. Now, we didn't really save a whole lot of time because this was really one line, but we can write bigger and bigger and bigger functions here to do more complicated things each time. So one of my favorite things for a function is a menu. So we could define a menu like this will be our rock, paper, scissors, lizard, Spock menu here. So if you don't need to be given anything to call the function, you just have open and close parentheses. So if you need something to run, this is known as a parameter when you define it. So the prompt is a parameter here that we have access to inside the function. When you give it a value, it's technically known as an argument. Arguments and parameters, they're essentially the same thing, but some people like to be really pedantic and argue about terms. So sure, arguments or parameters. Okay, so when you are giving it the value to the argument, when you define it, it's a parameter. That's all we really care about. I usually call them arguments all the time. So we've done this before, right, where we've passed things to functions. We did math.ceil. We gave it a value, that was the argument, and it gave us back a result. But now we're learning to write our own that aren't in the Python library. So our rock, paper, scissors, lizard, Spock menu is just going to print out, please pick a choice, or how about enter a number. There we go. Enter a number. And then I'm going to do a couple prints here. So I'm going to use the tab. We don't even need a tab. We'll do 1 for rock. We'll print 2 for scissors. We'll print 3 for paper. We'll print 4 for lizard. And then we'll print 5 for Spock. Now, we can use input without giving it anything. So I can then get their choice is an int of an input. An input doesn't need to be given anything because I already printed out all these things. And what I like about this is I don't have to add in my own new lines. Right? If you were to give this menu inside of an input, you'd have to add in your own \n, those new line characters, which is kind of annoying. Maybe it's easier to type \n than print, but I prefer this. So we can get their input as a choice here, and then we can return their choice. Right, so now we have a menu. So anytime I want to play rock, paper, scissors here, we'll get the user's throw is my rock, paper, scissors, lizard menu, rock, paper, scissors, lizard, Spock menu here. It will return a value, so I can assign it to user's throw. Okay. Then we got to make the computer's throw again, right? Computer throw is going to be random rand.randint 1 to 5. Oh, we got to import random, right? .randint. So sometimes it's helpful when it'll suggest you import here with these little suggestions here. The other options are not very good. You don't usually want to click on them, but if it knows what random is, it knows how to import it here. Give us the ugly import. That's fine. We'll just import random. We haven't talked about that other form yet, so this is probably easier. Okay, it'll be the random number. And I've got an integer result, right, for my choice here. Then what I can do is I can write another function. So we'll define a function for determine win, lose, draw, given a player choice and a computer choice. So if I give you 2 values, right, if you want more than one value, you just comma separate them here. Like when we did prints here, you could give print test again, right? You can give it more than one value, you just comma separate it here. You can ask for more than one value as arguments. Sorry. You just comma separate. So if you want more than one thing, you can do that. So win, lose, or draw. Again, we'll say, hey, if player choice is equal to the computer choice, we'll print draw. Right? And we could do the other ones here in a minute, but we don't need to necessarily have them all in here. But now I have determine win, lose, or draw. Right? And I can use that as a function. So I can then just say, hey, determine win, lose, or draw, given the user throw, comma, the computer throw. And if we wanted to, we could even make this a function, just for fun here. So I'm going to cut that out, and I'll say, I don't know, get computer throw here, and we'll go make another function for it, just because we can. Get computer throw. Doesn't need any arguments, and it just returns a random value 1 to 5. Not a very interesting function here, but what we've done is we put a name to it. How about get random computer throw? How about that? Random computer throw. I like that. Get random computer throw. That's probably a little cleaner here. So then our program here, if this is what we're looking at for rock, paper, scissors, is 3 functions. The part of our code that is not in a function is get the menu, get the random computer throw, determine win, lose, or draw. So without actually reading any of these functions here, just seeing the name of the function, hopefully you have a feel for what's happening. Okay, I'm displaying the menu and getting a result, maybe. I'm getting the random computer throw, and I'm determining win, lose, or draw. If I then wanted to, I could go and read the functions if I cared to see how it actually did what it was supposed to do. Just like the Python library, though. Like if I ask for a random number 1 to 5, do I really care how Python generates a random number 1 to 5? Or do I just care that it did the thing I asked it to do? Most of the time, we just care that it did what we asked it to do. So you can simplify your code and make it generally a little cleaner and easier to read by using functions. Now, I haven't gotten rid of any duplicate code, right? The first thing we said is if you have the same code twice, you should feel bad about yourself. I don't have any code twice. I didn't have any code twice. I haven't gotten rid of any duplicate code. But what I've gained is I put names to what's happening. And then if you care, you can go look at each individual step. So one of my favorite technical terms here is functional decomposition. Right? We're going to take a big problem and we're going to break it down piece by piece by piece by piece into smaller and smaller and smaller functions. Because that's how we make the computer solve problems. You can't give the computer a big problem and say solve it. You have to spell everything out for the computer, little step by little step by little step by little step. Step by step by step by step. Break it down into smaller and smaller problems. So these are my small problems here. Okay? Yeah, Alt-Shift-Enter. That brings up the little suggestion box. That's nice. What is it? Yeah, so it even knows here, print doesn't return anything. Those little yellow lines. Remember, the yellow lines are just warnings. They're not errors. It's not going to keep you from running. It's not going to crash it, but it's telling you, hey, you did a bad thing here. Right? Why are you saving the result if it doesn't return anything? So it's trying to be helpful here. Okay, so we've got our functions. I think maybe we just go copy paste our own code here. Let's go do that. So let's go look at lab 2 main. Now I still need these values, right? The rock, paper, scissors, spot, because that'll make my code cleaner here. If I wanted to, I could define them just inside of my determine win, lose, or draw here. Right? I don't need to define them anywhere else. So when you, inside your function, you can have variables. What's cool about these is there's a term called scope. This variable rock only exists inside of this function. As soon as this function is done running, there is no variable rock in the rest of the code. So I can't say print rock. Down here it says, I don't know what a rock is. Unresolved reference rock. You don't have a variable named rock. This variable only exists inside the function here. Right? So it, again, can kind of keep things separated and grouped into nice little pieces here. So we could do that. And then, so we got draw, and then we'll go copy paste from here. Here's our else if. Okay, computer throw. Oh, I have computer choice. Oops. So let's see. So I have user throw and computer throw. Mine was called computer choice. So I'm just going to go find and replace. Right? That was, I think, I don't know, where is it here? Edit, find, and replace. So let's replace computer throw with computer choice. Right, so I want to find all the times I say computer throw, replace it with computer choice. Now, I also did it down here, and I don't want to replace there. So don't use the replace all. That's usually a little bit risky here. The other thing you can do, which is even better than find and replace, once we have functions, essentially, I don't know, it'll work other times too. If you right-click on this here, you can go to this refactor menu, and you can say rename. It's going to do a smart find and replace, and say, okay, no longer computer throw, I want this to be computer choice here. And I can preview, it's going to show me all the places it's going to change it here. So it's going to say, hey, I'm going to replace it 12 times here with computer throw with computer choice. Let's see. Where's it? Oh, okay, so these are all inside the function here, right? So this one it'll replace, this one will replace this one. So it's showing me here. It's a little bit funnier to navigate here. And maybe I don't actually want it to replace some of these other locations. So depending on what you're doing, it's nice. Otherwise, it can be a little funny here. But now I have computer choice in all my menus here. But it also changed it. Let's see, where else did it change it? Computer choice down here. So it said, oh, computer choice and computer choice. That's fine. No big deal here. And now, oh, I have player choice and users throw. Oh my goodness. Oh, we got to do the same thing. So let's replace users throw, refactor, rename. And we want to change that to player choice. Now we'll refactor. We'll replace it all here. Okay, so player choice, player choice, player choice. So should fix it all up. So we've got some functions here. Okay, some functions have arguments. They return values. Some functions don't return anything, right? This function here, determine when, lose, or draw, all does is print something. It doesn't return any particular values here. Right, so if we were to try and assign something from it, it wouldn't have any answers, or wouldn't have any output. It'd just be a none. All right, we're close to 7. Before we start the next piece of this here, why don't we call a break? We'll take 10, and we'll come back and talk more about functions. Sound good? All right, let me put the music back on. We'll go from there. Functions to talk about. So the first thing, Python, remember you might have noticed you can give weird values to things and it doesn't care, or it just crashes. So in our function here, right, nothing tells Python that player choice needs to be an integer. We just need to give it an integer, right, for this math to work because we're comparing it to integers. But if I wanted to, instead of doing this player choice, or we'll just do it again, I guess, determine, we can say rock and paper. You think this is going to work? If I give it rock and paper instead of integers? Right. Python will run it. Let's run in the debug and see what happens. All right, so length and width, sure. We'll take out the breakpoint. I'll just continue here for a second. 10 and 10. All right, rock, paper, scissors, enter a number. Well, 1. We win. All right, so now we got to our breakpoint. Sure. So I'm going to step into our code and see what happens. So we gave it player choice. That was rock, and computer choice is paper. Now we're going to assign these local variables, rock, paper, scissors, lizard, Spock. And we're going to say, okay, if they equal, we printed draw. Well, they didn't equal. And now, is player choice ever going to equal a 1? Or a 2, or a 3, or a 4? No? Okay, so that if is never going to be true. Sorry, it's stepping over a bunch of those. Come on. Come on. There. So the else will always be true here, right? Because we didn't give it something that would make this true ever. And Python lets us do it. So if you give it something that it doesn't expect, in this case it doesn't crash, but we get a bad result, right? We should have, actually, I guess we should have lost a paper. Okay. Maybe we got the right result. But in general, probably not going to get the right thing. So if we wanted to write our own function here, like define, how about sum of values? How about value 1 and value 2? Sure. And we'll say here's our result is value 1 plus value 2, and then we'll return the result. Not a very interesting function here. Result, there we go. But it'll do something, so we can have sum of values. Yeah, it's a so Python does something known as duck typing. So in other languages, many other languages you might know are strongly typed, like C++ and C# and Java are strongly typed. You have to tell it what type of value you're storing for it to figure it out. Python and JavaScript essentially do duck typing. If it looks like a duck, talks like a duck, and sounds like a duck, it's probably a duck. So if it looks like an integer, acts like an integer, it probably is an integer. So there's no forcing the type in here with these. So we can use this function here, sum of values, and let's print these out here. So we'll print the sum of values of, how about 4 and 2, right? If you give more than one argument, they're just comma separated. And then we can also print the sum of values, how about apple and banana. Apple, banana. And I'm just going to run this one here. So length and width, 1. So 4 plus 2 is 6. Sum of apple and banana is apple, banana. Remember in Python, you can add, it's not really adding, you can take two strings and concatenate them. And Python says, sure, go for it. Why not? Now, what if we try and say, hey, I want the sum of apple and 2. 10. Pick rock, and now we get, oh, can only concatenate string, not int to string. Python says that's no good. You can't take a string and add an integer to it. Right? Which is weird, this one doesn't work, right? Because we can, right, we should be able to print apple. Do we get plus 2 here? Maybe we don't get that one. Let's try that. Where do I want to put that? How about up here? Let's run it. Nope, doesn't work here either. Okay. You can multiply. That's what you can multiply strings. That's right. So if we were to do product, we'd get some really weird things here, but you can't take a product of 2 strings. So you get some weird results. So if we want a product of 2 values, value 1 and value 2, and we get a result is value 1 times value 2, return the result. Sure, we can get the product. Again, once 2 lines here, that's sure. So that one will crash here. We know that one. How about a product of 4 and 2 and product, oh, we should print, right? And product of apple and banana doesn't work, but we can print the product of, apple and 4. No semicolons. This is not that language. Length and width and rock. So 4 and 2 is a sum. Apple and banana is a sum. 4 times 2 is a product. Apple and 4 is a product. Apple, 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 apple. Right? And then it crashes because you can't take 2 strings together. So it's going to try. So there's nothing forcing these to do what we expect it to do here, which is a little unfortunate. But you just, this is how it works. So when you write a function, nothing forces it to be a particular value. Okay, I think we could try, hey, if I want an int of a value here, I think int will work. If we wanted to do that and say, okay, let's turn them into integers explicitly, we get, you can't take an int of apple. So at least it won't give us apple banana here when we try and call it with apple banana. So these errors here are a little funky. You read them essentially from the bottom up. So once we start adding functions, we get 2 different line numbers here. It says, hey, it errored at line 5, right, which is right here. But how did we get to line 5? Well, we got to line 5 from line 72. And these are actually links. I can click on it. It'll jump me right to that line 72. So if you're getting errors, you can see, okay, well, line 72 gave me a call to line 5, which now failed here because I tried to take apple and banana, and those aren't integers. So you can do maybe a little bit of checking if you really want to, but it's going to be a little awkward. Right, so that's functions take any type of values. We can't really force it. So if it's really important, then you probably want to check for it. Another fun thing functions can do here, let's define first, and then how about we take a value here, and then we'll just print the value, and then I want another function. Let's have a function second that takes a value, and in this one we'll print the value. So I'll print the value, and then what I want to do from this function, you can call another function. Now, we were doing that already, right? We were calling int and input already, but you can call your own functions as well. So I could, from first, I could call second, given value +1. And then second, if we wanted to, right? We could have another function here for third. Takes a third, that takes a value. I think I've had too much caffeine, actually. I'm a little shaky. I feel good, though. Let's print the value. And then second, and we'll call third here, given the value +1. Why not? Right, we'll have just this little chain. So first we'll call second we'll call third will print here. Okay, so it likes two empty spaces between functions here. So if you get those yellow lines a lot, sometimes you can ignore them. I usually try to, but sometimes it bothers me. Yeah, you can do Dota 2. You can do operator overloading. We're not going to get into that for quite a while. So I need to do this before I crash, right? Before these ones will crash here. So let's call, how about we just call first, and we give it a value. What number should we start with? 5. All right, we'll give it a value of 5. So we should get 5 out of first. Where'd first go? Should print 5, and then should hand second. 5 plus 1 is 6. Second should print 6. Call third with 6 plus 1 will be 7. Third should print 7. Right? So we get a run, length, width, and rock. Sure. We get 5, 6, 7. Right? That was kind of in the middle here. This output here is a little funky here because we're just jamming everything together. We get first, second, and third. So if we put it in debug mode, I can put a breakpoint in the function here and run it in debug mode. Length and width and rock. Now we get, okay, oh, we have this one. Let's continue. We got first, value is 5. So again, we started at main, line 85. Now I'm at the first function, line 14. And we can step into our code. Now we're at the second function, line 9, step into our code. Or the third function. So when third is done, they'll go back to second. When second's done, they'll go back to first. When first is done, they'll go back to main. Right? As many of these as you want to do. Now, here's a silly thing. If you wanted to, and I don't recommend you do this at home, but you can call first given value +1. Where first we'll call second, second we'll call third, third we'll call first, first we'll call second, second we'll call third. What do you think we're going to get? A big old loop. Eventually it will crash. Maximum recursion depth exceeded while calling a Python object. So Python does this cool thing. When a function calls itself, or like eventually will call itself, or first called second, second called third, third called first, that's known as recursion. You can only do that so many times before Python pukes on you, because it can only has so much memory. So when we looked at Python, remember we were at main, then we were at first, and we were at second, we were at third. It has to remember all of that. The computer has to track all of that in memory. If you do it too many times, the computer gets really sad. Now, we didn't run out of memory. We only did like 1,000 of these. But generally, if you've gone that far, you've probably gone too far. So we get all sorts of errors here. Eventually, we'll get some output, though, up here. We get, yeah, right about 1,000 or so, right? Oh, exactly 1,000. That's crazy. Before it puked. Right, so it did it a bunch, and it did it really quick. We didn't even notice before it started crashing. We got all the output. And it just kept on going until it reached that limit here. So, again, don't recommend doing that. I'll just comment that out here, which is fun. Probably a better example of this here. We'll get more into recursion later. I want to show you, this is, the countdown is a really simple one. Given a value, we'll print the value, and then if the value is greater than 0, we'll call countdown, given value -1. So this function will just call itself directly. So if you get a value, it'll print it, and then if it's greater than 0, it'll do it again with that value -1. So if I give it 10, I'll get 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0. And then 0 is not greater than 0, and it stops. Nothing else to run. You know, I should just put these at the top. This is what I should be doing here, ahead of length and width. So we'll have countdown of 10. And I'll put a breakpoint here, and we can watch it run. So countdown is 10. I want to step into my code. Value's 10. We printed it. It's less than 0. Let's count down again. Oh, I didn't step into my code. I stepped over. Let me try that one more time. Debug. The wrong button got me. Step into, step into. Hey, thanks so much for following along. We see 8, we see 7, we see 6, 5, values 5, values 4, values 3. And you see, they just keep adding here to this call stack. So here is main, here is countdown of 7, here is countdown of 7. But each one of these, when I click on it, will show me what the value of my variables are. So value, I mean, we call it value here. We can see it has different values in each one of these calls. So this is what Python's tracking behind the scenes. It's every one of these that has to track all of its variables and where it left off. And that's why you can only have like 1,000 of them before it crashes. You can override that behavior. There's a setting in Python you can change. We're never going to need to. So we keep on going. We see now value is 2. We keep on going. Value is 1. Keep on going. Value is 0. All right, now we're going to print 0. It is not less than 0. So there is no else. Nothing else happens. So we're going to start seeing these come off of the call stack. Right? Once it's done, it comes off and it goes back to where it left off below that. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and we're back to countdown. And in our output here, we get counting down. Right? So that's recursion, is when a method calls itself. Method calling itself. If you continue on to take other programming courses, particularly in data structures and algorithms analysis, recursion is huge. It's really good at solving a specific type of problem. Yeah, is that a question?
Yeah. What do you mean a method?
Sorry, a function. Sorry. Yeah.
Okay.
In other languages, they're called methods. In Python, they're called functions, and I just can't keep it straight in my head. So methods and functions, I'll use the terms interchangeably. Sorry.
Okay.
Yep. Yeah, when a function calls itself.
Or an argument.
So arguments and parameters are the same thing. So
Okay.
value is the argument here. No. So value is the parameter. When you give it to a function, it's known as the argument.
Okay. Mine Python goes in the room and goes, I came here for an argument. Oh, this is abuse. Arguments next door.
Nice. Yeah, it's people like to argue about words. I don't know. Sure. All right. Yeah, there's a lot of good things that recursion is good for. We'll get into that later. We're just kind of introing functions here right now. So that's functions calling itself. Functions can call other functions. Functions can have multiple parameters. Functions can have no parameters. Functions can return things or not return things. So lots of different flexibility with our functions here. But what we want to start doing is we think about when we're solving problems. If you're doing the exact same process every single time, and the only thing that's different is the value you're operating on, you should think, hey, that could be a function. Right? That idea of having the same code twice, we should feel bad about. If it's the same steps, no matter what you're working on, then that piece can be variable in a function. So probably a better example of that one here. Let's do, let's add another function here. Yeah, this is IntelliJ. Oh no, PyCharm. Yeah, PyCharm. They look the same here. Thanks, thanks, Dota. We got some folks here on chat. So if a function is going to do the same process, but what it's operating on is different, right? Then we can turn it into a function, and it should work out really well. So one of the things that we do a lot here is, what was the same steps here? So if we want to, let's do this up at the top. So before we count down, so if I were to ask you to enter a grade here, so we'll say, let's get a couple grades here. So we'll have grade 1, we'll have grade 2, we'll have grade 3. Is an int of an input, enter your score 0 to 100 here, and enter your score 0 to 100, and enter your score, or I don't know, your first score, second score, third score. How about that? 0 to 100. So we'll get 3 numbers here. And then let's add them together and get the average. right? So then we'll get an average score, average grade. I guess these should be scores, right? We'll call them scores. Score. I like that. Score and score. So average score is going to be score 1 plus score 2 plus score 3 plus score 1 divided by 3. And make sure you do order of operations here, right? Add them all together first, divide by 3. Now I have the average here. So if I wanted to curve these scores, right, which is actually a misnomer, because most of the time when college students think of curve, they think, okay, well, whatever the highest score was, take the difference between that and 100 and give those points to everybody. That's not a curve, that's a bump, right? A curve is generally the standard distribution, and the standard distribution looks like this. So actually curving scores would mean the majority of scores become the middle here, which is a C. Very few people get an A and very few people fail. So some classes used to do this, and it was back when college was mean, I feel like, and they're like, it's really hard to get an A. Only a couple of people should get an A. Only the top 5% should get an A. They would curve the scores. And you literally could not get an A unless you're in the top 5% of students, regardless of how many points you got on things. Right? That's a curve. Nobody wants a curve. Curves are bad, okay? I mean, sure, because only 5% of people fail, maybe people are okay with that. But I feel like being told you get a C just because you weren't the top 5% is mean. Maybe that's just me. So, I don't know. Maybe it's good if 95% of people pass, like automatically. But again, that's the curve. So we don't want to curve. We want to bump their score and take, okay, if the highest score was 90, then let's make the 90 a 100% by adding 10 to it. So we figure out what the average is, and then we'll figure out the difference from 100 is 100 minus the average score. And then we'll take score 1, score 3 plus equals the difference, and score 2 plus equals the difference, and score 1 plus equals the difference from 100. Right? Can we do that? So add whatever the difference was to all the scores. Print out, I don't know, adjusted or bumped score 1. Score 1 is score 1, and bumped score 2, and on and on and on. Score 2 and score 3. Nope. I think I got the page up key there. Does that make sense, what we're doing here? So enter 3 scores, figure out the average, figure out how much off of 100 that was, and then we'll add that difference to everybody. And this is actually this is the average. We didn't even do the highest. I did this wrong. This is making the average score 100. That's my mistake. So we want the highest score here. Oops. Well, the highest score, okay, we got to figure that one out. So forget average for now. We'll come back to average. Let's say the highest score, we'll assume it's score 1 until we know otherwise. I mean, say, hey, if score 2 is greater than the highest score, the highest score becomes score 2. And then if score 3 is higher than the highest score becomes score 3. Right, can we do that? And then we'll get our difference between 100. Here we go. So our difference from 100 is 100 minus the highest score. No wonder you guys were looking at me funny. Right, so if the highest score was 90, then we'll give everyone 10 points. And this is generally a relatively fair way to assess people. I like to look at if everyone got the question wrong, it's probably a bad question. So I generally don't say, okay, well, you know, if the highest score got this question wrong and other people got a different question wrong, well, it's just a different thing. But if everyone got a question wrong, then we can just get rid of that question because it was trash. So then we can add in those differences, get their scores, and those are the bumped scores, right? So if we get, how about a 80, a 90, and a 70, we should get a 90, 100, and then 80, right? When they're bumped. That works out okay. But we're doing sort of like the same operation a bunch of times here. Now, this is not the largest operation here. And we're not doing a ton of different work here, but we could turn it into a function if we wanted, right? Where you give it a score and you give it the difference and it'll give you the result. It's not much different than our sum two things though, right? Sum of values, like just adding 2 together. So not quite there yet. But what we could do, right, if we had more arithmetic that we were doing in here, Also looking at, hey, if we're above the average or below the average, we could do some other things here. So let's add in some of that math. We'll say, hey, if you're above the average, you'll get less than that whole amount. And if you're below the average, you'll get that entire amount. Okay, so we'll say we still need the average then. So we'll calculate the average score again. This difference was wrong here. So that way, the highest score, we're not actually going to bump up to 100 because it was above the average. So we can say, hey, if score 3 is greater than the average score, then they only get, how about maybe half the bump divided by 2. So this is, we'll say if score is above the average, we'll give half the bump. So that way we're bumping up people below the average more than the people above the average, right? Trying to help them out a little bit here. Otherwise, our score 3 then plus equals the whole difference, right? Just a contrived example. I don't know if we would actually do anything like this, but why not? Score 2, score 2, score 2. And then score 1, score 1, score 1. Okay. So now if you're the highest score, you're not going to get the whole bump. Right? So if we had 80, 90, and 70, right? The average should be 80 here. So 80 won't get the whole bump and 90 won't get the whole bump. Oh no, I'm sorry, 80 will, because 80 is not greater than 80. So it should get the entire bump, right? So we should get 95, 90, and 80, right? Let's see, 90, 95, and 80. But now we have like the same code essentially in here twice, and the only thing that's different is this variable. Now I feel bad about myself. I have the same code twice. Even though it's not the exact same line, it's the same process. So now this probably makes more sense to be a function. Again, it could have been a function before. Oh, I'm sorry, my backpack's in the way. But it didn't have to be. So let's go make a function. So we'll make this, this is what, add difference from 100 to score less greater than average. I don't know, it's ridiculously long, but sure, we want to put a nice name to it. Why not? So we need a couple pieces of information here. We need the score, right? We need the difference from 100, and we need the average, right? You need all three of those things here to know what the answer is. That's a little too long here. Oh goodness. How about we'll just say bump. Bump score unless greater than average. How about that? Does that look a little nicer? It could have been long. So my font zoomed in a lot. It would have fit on a normal size screen here, but okay. So our function bump score unless greater than average. So given the score, if the score is greater than the average, let's take score plus equals the difference from 100 divided by 2. Otherwise, the score plus equals the difference from 100. And then we'll return the score. Right? We want to return something they can get a value back. Now all we have to do is call our function every time. So instead of having to do this if, else, if, else, if, else, if every time, right? We just do it 3 times. Where'd it go here? So this one here. Should I, let me leave that here with the comment here. So I'll leave that in. That was the previous version. So we'll have score 1. We'll have the difference. And we'll have the average. Right? We'll give it the 3 things that that function needs. Score 1, score 2, score 3. Now, a fun thing here, you'll notice if I give it score 1, it's changing score 1 inside the function. Right? Well, it's changing what's known as score. But when you pass a value in Python, you're passing a copy of that value. So when I say, hey, here's score 1, and I change score 1 inside the function, it's not going to change score 1 outside the function. So just running this here, like if I put a breakpoint in, and we run this in debug mode, we'll enter our scores. We had 80, 90, and 70. Now we're getting here. So score 1 is 80. If we step into our function, the score is 80, the difference is 10, and the average is 80. Okay, sure. We'll take score. It's not greater than the average, right? 80 is not greater than 80, so we get the whole bump. So now score is 90. We're going to return score, but when this function's done, score 1 is still 80. We didn't change the value of that value we gave it. Because what we did is we said, hey, Python, here is what the value is. You can't change it from where we're storing it. So if I don't assign anything ever, the scores never get bumped, right? It's going to tell me the same scores right back out because I never bumped them. So you need to be a little bit careful and make sure you're going to assign them back. So we'll say, hey, score 1 is equal to the bump. And score 2 is equal to the bump. Score 3 is equal to the bump. We need to assign the value turned because when it is passed to the function is passed as a copy. Now that's not going to make necessarily a whole lot of sense right now, but what it means is when you give a value to a function, it's not going to change it on you where you're keeping it. And the reason why that works is, remember when Python keeps track of values, it's actually tracking the memory address of where that value is in memory, right? So like it asks the operating system, hey, I need a place to store an integer. It needs 4 bytes. Did we talk about that like the very first week? It's been a while, right? And the operating system says, sure, go store it at like x29f2 because they use hexadecimal addresses for some reason. Why not? You're keeping that memory address for where that value is, and when you call the function, you're not giving it the memory address. You're giving it, hey, here's the value of 80. So when it changes that 80, it's not changing what's written in memory. You still have that value 80 written in memory, and it doesn't change until you say, hey, Python, go change what's stored in memory for this value. Go change it. Go change it. Right, so let's make sure it works here. Let's give it a run. So we give it 80, 90, and 100. We should give back 90, 95. Oops, oh, nope, I give it 100. That was wrong. 80, 90, and 70. Let me rerun it here. 80, 90, and 70. There we go. We get 90, 95, and 80. So we now have a bump. We don't give the highest score an A. We don't give them an A+. We give them a solid A, but not an A+. How about that? Right? So, sure. This is our silly system. But when we're looking at our code, right, if we're doing the same operation and the only thing that's different is the value, we should be thinking in our head, hey, this could be a function. Right? We can make a function out of this. We can make a function out of this. We can make a function out of this because it's the same steps. And that's what matters is, are we doing the same steps here? And if the only thing is different is the value, well, sure, we can make the function and we can give it that value. We got a lot of functions here, friends. We'll give it the score. It can do that same arithmetic every time. What is it? This shadows name thing is annoying. So if you have a parameter with the same name, it gets confused. I wouldn't worry about it. It's just annoying. All right, let's take a look real quick. Py4e. We don't want conditionals. We want the next chapter. See if we got everything here. So function calls, built-in functions, we've used those. Max and min are fun. Type conversions, we used those. We did strings, we did math things. Sine and cosine, sure, radians, those are fun. Random numbers, we did random numbers. And then adding new functions, right? This is the interesting piece where we started looking at. With our own functions, we can build our own. A function can call a function. Sure, we did that one. We did that one. Our flows, we have parameters and arguments, right? Can do that. Fruitful functions and void functions. So void is a word in other languages. I don't usually like to use it in Python. If you don't return a value, you're known as void. And in other languages, you actually use the word void when you declare functions or create functions or methods. And fruitful is it's going to return something. It will give you back a value. This here is Dr. Chuck's wording for it. And then why functions. Again, you can name the group of statements. easy to read, understand, and debug. This is my favorite reason for functions. Even if you're not saving any code at all, it actually takes more lines of code to write those functions like you did for rock, paper, scissors. Right? Overall, I had more lines of code there. I didn't save anything, but I put a nice name to, okay, ask the user, generate one for the computer, determine win, lose, or draw. So you could see those 3 steps that were happening there. Then you can eliminate duplicate code, repetitive code. Great. And the benefit of that is if it changes, you only have to change it one place. Right? If I had an error and I copy paste like that Collat's conjecture, I think I did have an error, didn't I, in that at one point? When I copy pasted it like 20 times to show 2 weeks ago, like, hey, we can multiply by 3 and add 1 if it's odd. Right? If I had an error there, I'd have to change it 20 times. I mean, find and replace makes that a little easier, but generally it's easier to change one place. This divide and conquer, functional decomposition. Now, if any of you go to a 4th of July party and you drop that term in the middle of your family conversations, I will give you a bonus point on one of your quizzes. Because, I mean, my family knows I'm a giant nerd. It's no surprise there. I don't know what your families think about you folks. But if you're just, you know, hell man, I was working on this project and had to do all this functional decomposition, you could just like look at everyone's eyes and be like, what did he just say? And it's just really funny. So if you record that and show me, I'll give you a bonus point on one of your quizzes here. I don't know. My kids are all turning out to be nerds, and I tell them they should be proud of it because nerds are going to run the world. Like maybe the politicians, the rich people do, but I'd like to pretend the nerds will run the world when we figure out how to tell computers what to do. Then the other piece, we haven't gotten there yet, but the Python library, all the things in the Python library that we've used are functions, right? Once you've written it, you can use it anywhere you want. So Python has this great library of functions that do things right out of the box because someone wrote it once, and now we just get to use it. Eventually, when we solve big and amazing problems here, we're going to write our own function, and we can let anyone in the world use it. That's one of the coolest things about programming. People write open source software, and they say, hey, I wrote a really cool thing. Do you want it? And they just put it out there for free. Like Linux. It's an entire operating system. Right? Someone wrote, Mr. Linus Torvald started and said, hey, I did a cool thing. Do you guys want it? Right? It's amazing. So we can reuse those small pieces here. It doesn't have to be anything huge. It could be a small piece here. Right? Like if we wanted to, we could write a function to calculate an average here. It's not very interesting, but we could. Right? Define average of values, given value 1, value 2, and value 3. Right? We can just do this all in one line. So I generally, sometimes I like one-line functions and other times I don't. They're harder to debug if you do it all in one line. So you could say return value 1 plus value 2 plus value 3 divided by 3, all in one line here. The problem with this is you never get a chance to see what the value is before you return it. So I feel like it's harder to debug. So I generally will try and do these in 2 steps. So I'll have a result is something, and then I'll return the result. Because that way, if I'm debugging my code, I can put the breakpoint here and say, okay, what did you come up with before I go and return the value? Yeah.
Could you show us really quick how to do the array of values?
We will get to that in, come on, hit the middle button. Lists, chapter 8.
Oh, okay.
Yeah. Yeah, so if you've done other programming, you know an array is a bunch of values. We'll get to that when we talk about lists. So I try not to get too far ahead into other things, if that's okay. We can talk about it later if you want, for sure.
I just thought that that would be more useful.
Yeah.
Array in
Yeah.
average.
Yeah, you could definitely do, that would be easier than trying to say, here's an average of 3 values specifically. Yeah. Okay. So let me see, what else do we get in functions here? Some other cool things about functions too. Here. Let's do this. So this is not in the chapter. This is like fun stuff here because Python's really cool. Average is only so useful because I have to have 3 values every single time. Right, but why not? We can go use it here. So we'll go find where we're doing our average. Where is it here? Here's the average score is average of score 1, or I don't know, 1, score 2, score 3. Comma separate. Sure, we'll get that. But what if I had 5 values, right? Or something like that. So what we can do is you can have parameters with default values. So I can say, okay, hey, let me add in a value 4, and I'll say, it will default to 0. So if you don't tell me what the value is for it, I'll assume it's a 0. And we'll have value 5, we'll default it to 0. And value 6, we'll default it to 0. Value 6, default to 0. And I'll stop at 7, because that's probably ridiculous here. But then what we can do, and really we can do this with all of these here. The average of 1 is silly here, but that's okay. We will default these values here. So if you don't give me the value, I'll assume it's a 0. So I can say, hey, here's my sum is starting at value 1, and then if value 2 does not equal 0, I mean, 0 is actually maybe a little bit funny here, because 0 might be a valid result. I don't know. We'll pretend 0 is not valid here. If 0, 0 is a valid score. Right? Yeah, we could do -1, sure. -1, I like it. So you probably, so this works for scores, but like averaging, maybe -1's a valid value, but sure, yeah. -1, -1, -1, goodness, we got too many of these things here. -1, -1. So if the value is not -1, then I'll take the sum plus equals value 2, right? And we're going to check all of these things and say, okay, if it's not a -1, let's go add it to the sum. Now, the other thing I need to do is count how many values I have, though. This is my count of values. Count of values starts off at 1 because I'm assuming value 1 is here. You're not going to sum no numbers here. So if it's not 1, I'll take count of values plus 1. Right? And then we'll do the same thing. Right? So then value 3, add in 3. If number 4 is not -1, let's add in value 4. If 5 is not -1, let's add in value 5. If 6 is not -1, add in 6. 7. You can grab multiple lines, by the way. I don't know if you've seen that, and tab them or untab them. Shift tab is to untab, tab is to tab. I don't know if you've seen me do that. I love shortcuts. So if the value is not a -1, let's add it to the sum and add it to the count. So then my result here will be my sum divided by the count of values. When we're done, we can return that result. Okay, so then what I can do with this average of values, where are we doing it down here? Average of values, this is perfectly fine. I can give it 3 things. I could also have an average of values given 10 things, or 7 things, right? 7 is our max. So 10, 20, 30, 40, 50, 60, 70. That's fine. I could give it, I don't know, 5 things, right? 10, 20, 30, 40. 4 things. Python is fine with this because it fits. If you call a function and it fits, it'll work for you. So this is optional parameters here, or optional / default parameters. Parameters. So I can say, okay, if you don't give me the value, I'll assume it's this. And then you can use something and check for it certain ways here, which is fine. All right, another fun one here is, this will be our citation generator. Right, so you need to give me the book, how about the title, the author, the publisher, the year published. So like if you're going to cite a source here for papers, right, you need all this information for your works cited page or your references page, right, whether or not it's MLA or APA. That's a bunch of things here, and we might even have more in here. I forget all the things we have to add because Microsoft Word like does it for you now. Sure, and we'll print out what is it? You do the title, and then, or no, you do the author, and then you do the title, and then you do the year, I forget, and then you do the publisher or something. There's some silly format here. It's not correct. Whatever actually works here. Now, 4 things is not too bad here, but what I can do when I go and actually use this citation generator, like if I were to ask the user for all those things and say, hey, here's the author, is an input, enter the author, and the title is an input, enter the title, and the publisher is an input, enter the publisher, and the year is an input year. I don't care if it's arithmetic, so I'm not going to turn this into an integer. You could if you wanted to, but that's fine. Now, when I call that function, the citation generator, I might not remember what order they go in. Now, PyCharm's telling me, hey, it's title, author, publisher, and year published. It's trying to help me here, which is really nice. But what I can do, if you want, you can name your parameters. I can say, hey, author is equal to my variable author, comma, my publisher is equal to the variable publisher. Now, this is a little silly because they're named the same thing. So it can look a little funny here, but you can do that. So, and then we can have year is, oh, I'm sorry, year published is equal to the year. And then what do we have? The title is equal to the title. So this is using named parameters. Parameters. So instead of giving them in order, right, where the order that I asked for them was title, author, publisher, year, you can give them any order you want, as long as you tell Python what that order is. Instead of giving them in order, you tell Python what order they are in. Right? So I can say, okay, I'll give you the author first, and then I'll give you the publisher, then I'll give you the year published, then I'll give you the title. I don't care which way you wanted it. I want to give it to you this way. And this is kind of helpful, too, for functions that take a lot of variables, or a lot of arguments, or a lot of parameters, because it's really easy to get them mixed up, even with it trying to help you. Like when I started typing citation generator, it said, hey, give me these 4 things. I don't know what they are, right? And we can do the same thing with our average of values here. I could say, hey, value 5 is equal to 27, if I wanted to, right? I don't know why you do these out of order, but you could. Now, the only thing you have to be careful about here is I can't just say value 5 here. So arguments, the technical term for this is positional. Usually we give them by position. The first thing, the second thing, the third thing, the fourth thing. And when you call the function, the first thing matches the first thing, the second thing matches the second thing, the third thing matches the third thing, right? They're matched by position. You gave me the first value, it must be the first thing. With named arguments, we're no longer positional here. And then this messes up all of our defaults. Because remember, value 1 didn't have a default. There was no default for value 1. It's going to be real upset with that. Stop and run. Let's give it some gibberish here. And then it crashes. We get average of values missing 1 required positional argument. So if you want to name parameters, you have to do the positional ones first or include the positional ones. So if you wanted to do them out of order, you could, but you have to then include the ones that don't have defaults. And that can get a little funny because it's hard to remember what ones have defaults and what ones don't have defaults. So I could give it value 1 here and it would be okay. Right? SDF. Sure. Right? This is okay now, as long as we gave it the one that doesn't have a default. So you have to give the required positional without defaults arguments. Does that make sense what that note is? Right? Otherwise it just fails. It's no good here. Okay. We've been going for almost another hour. We need to talk about the lab and the next project. Do you want to take a break first, or do you just want to talk about them? All right, someone online said break. They were the first person to answer the question, so they win. Generally, that's how things work. So we'll take a break. We'll come back and talk about the lab and the project. We can start working on the lab. You can get it done before you walk out the door. You can probably get started on the project. The lab hopefully won't take us another, more than an hour and a half or anything like that. So why don't we take 10? Well, might get another Coke. I'm not wired enough yet. And we'll go from there, okay? Put the music back on for folks online. This is Alrighty, folks. Moving on back here. So we got the lab and the project to talk about. Let's do the lab first. So one important thing here with functions is a lot of people, when they start writing functions, do all sorts of input in their functions instead of using arguments. Right? So if a function is supposed to take arguments, it should not ask the user to enter something. Right? That's why you're given an argument. You're given the value. You don't need to go ask the user to enter it again. Okay? The other great thing about functions is once they know how to work like this, the function doesn't care where the values come from. It's not tied to being a console-based application where the user has to type here at the console prompt. It could be used in a console application. It could be used in a graphical user interface application. It could be used in a web application. It could be used in a mobile app. Maybe phones run Python. Probably not. But you can use it in more than one place. So the only place you can use a function that does input here is at the console. So later on when we look at graphical programs, you can't use that function in your graphical program because the user has no place to type something for these functions. So if it's supposed to take a parameter, it needs to use that parameter. Okay, so what we're going to do is we're going to write two functions. We're going to write an affirmation generator that generates a random value 1 to 5 and prints a different affirmation for each value. So if it generates a 1, you print out affirmation 1. Prints a 2, you get a 2, you print out affirmation 2. So this doesn't need any arguments, and it doesn't need to return anything. It just does something here. Okay, so if you're not sure, you can look up the affirmation generator here, and this will give you several affirmations, right? And you just copy paste. I don't care, right? Just, these are fine. You don't even need to, like, this is just text you're spitting out. I don't need you to cite a source here. This isn't the code portion. So go for it. Or come up with your own 5, right? Doesn't matter. We're just, we'll give someone a nice affirmation for the day, and maybe they'll feel better about themselves, which weirdly enough, positive thinking seriously has an impact on people, like and on their mental health. It's the people, like humans, are the craziest, like biological machines. It's like just by thinking things you can change. I don't know. It's crazy. That sort of sociology or psychology stuff. I think it's psychology, right? Just way over my head, but it's super interesting. Okay, so that's the first function, is the affirmation generator. The next function, this one's a little bit more involved here, accepts values for a, b, and c. This means you will take them as parameters or arguments for a, b, and c, and then we will solve the quadratic equation of ax squared plus bx plus c equals 0. We're going to calculate the x-intercepts and return them, or return a string saying they don't exist. That's the other fun thing. I didn't get to this one here. Python, you can return more than one thing. Let me show you one of those real quick here. So we'll write a function for what to wear given the weather. So if you give me the weather, I'll return what to wear. We can say, hey, if the weather is equal to sunny, we're going to return sunscreen. Otherwise, right, if it's not sunny, we'll return a jacket. So you can have multiple returns here, right? And that's okay. And then because Python doesn't force things to be an integer or a string or something, you could even return like the number 10 here, and Python could care less. So you don't have to have the same type being returned each time. So we'll return the x-intercepts or a string. Right? Or just return the x-intercepts as a string, and then there are always strings here. So the quadratic equation here, right? Yeah, is there a question?
Yeah. So what does the return actually do?
So it gives the value back so that when you call that function, you can assign it somewhere. So like input gives us a value back that we can assign to author. So Python will hang on to that result. Our functions, like average of values, gives us a value back that we can assign to average score.
Yeah.
So the return is what tells Python to give this value back to wherever it was called. The return to that keyword after we figure out whatever we had to do here. So like we'll just return that choice for this one, or we'll return the value for these ones. Yep. Yeah, because some functions like our determine win, lose, or draw don't return anything. They just do their operation and then they stop. That's it. There's no return here in win, lose, or draw. If we wanted to, we could return the win, lose, or draw, I guess. That's an option too. So A, B, and C for the quadratic equation. Now, I didn't give you the link here because I don't know if you, whatever. We can just go Google it here. So the quadratic equation. It's got to be a good one here. How about Wikipedia? This one right here, quadratic formula. So x is equal to negative b plus or minus. So we have to do this 2 times, right? The first time is plus, the second time is minus. So negative b plus the square root of b squared minus 4ac, the whole thing divided by 2a. And the second x-intercept is negative b minus the square root of b squared minus 4ac, that whole thing divided by 2a. Now, if they don't exist, right? They don't exist if, where did it go here? This one, this b squared minus 4ac is less than 0, right? You can't take the square root of a negative number without imaginary numbers, and those are really imaginary here. So if b squared minus 4ac is negative, they don't exist. You don't have an x-intercept. That's when we would say this is no good. So let me add this in here because this is kind of crazy. I didn't want to copy paste it in because it kind of looks funny here. So x will equal negative b plus or, I don't know, how about x-intercept 1? Our first x-intercept. And then I feel like I'm writing the formula here for you, but you know, negative b plus the square root of b squared minus 4ac. That whole thing here, right? Divided by 2a. And then your second x-intercept B2A. Second x-intercept is b squared minus the square root of b squared minus 4ac divided by 2a. So if this thing here, if is negative, there are no intercepts. We've essentially written half the Python code already, but that's okay. I'm not too concerned. It's just practice here with our functions. Okay, so we're going to check to see if that thing's negative. There are no intercepts. Return a string saying they don't exist. If it's not negative, so 0 is okay, or positive. So not negative is okay. Then we'll calculate the first and second intercepts and return them. Feels like a lot of math. I promise it's not bad, and we can plug these in pretty easily here. So for exponents, there's two ways you can do exponents. You can do the multiplication sign, which is weird. I don't know if we actually looked at that one or not. So we'll print, how about 3 to the third is equal to, you do 2 multiplication signs is the exponent operator. I don't remember if we did that one or not. There's also math.pow. We'll do that as well. So you could say, how about 4 to the fourth equal to math.pow, and power takes the, I think it's the first thing and then the second. It's got to be the value and then the exponent. So either of these will work, math.pow or the exponent operator. Right? Pow short for power to the power of. Okay, so we can do those. Square root is a function in the math library. Right? Math.square root is how you'd square root something. So if you try and take the square root of a negative number, Python's going to be upset with you. It even has a math domain error. Yep. Right, so don't crash on square root of a negative. Right, that's no good. So that's what we're checking for. If that b squared minus 4ac is negative, this whole formula will just crash because you can't take the square root of a negative number. Right? It doesn't exist. Okay, so a little bit of math here. I promise it's not too bad. Gets to exercise some of the more of this fun stuff in Python. So just those two functions, right? The affirmation generator and then our quadratic equation intercept finder. Okay. Yes, if a is 0, it's not quadratic. Right. So if you don't have an x squared, it's not a quadratic formula. So a can't be 0. That I guess that's an assumption. Sorry. So your intercept would just be 0. Or I guess be c. My goodness, I haven't done math in forever. There's some intercept here. I don't know what it is, but it's not quadratic at that point, so it wouldn't work. What is it? It's something between b and c. Because c will put it up on the y-axis or down on the y-axis, so then it's some factor of b. Minus c divided by b? Okay. Cool. Yeah, but then you just have one intercept because it's a line. It's not a curve. All right, that's the lab. Then for the project, we're going to do a really basic, awful version of a tabletop role-playing game function because I'm a giant D&D nerd. So we're going to write out a bunch of functions in a program to simulate a couple things for a really bad ripoff of a tabletop role-playing game. So we're going to write functions that walk the user through creating a character and doing some basic actions, badly modified from 5th edition. So we're going to write a function for getName, asks the user to enter their character's name and returns the result. So this one will do an input and return the result, right? So getName will ask them to enter their name and return it. We're not really saving any code here, but we put a nice name to what we're doing, right? And then we need to save the name somewhere, like we're going to store the result of this. Then we're going to write a function, sum of 4 6-sided dice with lowest dropped. That's a big mouthful here. But what we're going to do, we're going to generate 4 random numbers 1 to 6, return the sum of the largest 3 of them. So a common way of generating stats here is you roll 4 6-sided dice, get rid of the smallest one. I actually don't like this way of doing it, but it's a fun exercise, right? So to find out which one is the smallest, right, you have to figure out and track which one is the smallest. So when you roll 1 die, that is the smallest. When you roll 2 dice, right, either the first one or the second one is the smallest. We know which one the smallest is. You roll the 3rd die, if it's smaller than the smallest, it's the new smallest. When you roll the 4th die, if it's smaller than the smallest, it's the new smallest. Right? We did that same sort of thing when we were looking at highest score, right? We said, hey, if you're greater than the highest, you're the new highest. If you're greater than the highest, you're the new highest. Right? You can do that each step of the way. The same thing with lowest, you're just less than. We're going to use that function to assign 6 variables: a strength, dexterity, constitution, intelligence, wisdom, and charisma. So this will definitely save us some time here because we're doing that same operation 6 times and just saving them with different names. These are our attributes for our character. Okay? Then we're going to write a function get ability modifier. It accepts a value for the ability score, which is this 3 to 18 thing here, right? 3 to 18, because the worst you could do is 4 ones. You get rid of one of them and you have 3. The best you could do is all 6s, but you only get to get 3 of your dice. So 6 times 3 is 18. So we only care about 3 to 18 here. It returns the correct modifier given this table here. So the modifier for ability scores, if you are a 3, you're -4. If you're a 4 to 5, it's -3. 6 to 7 is -2. 8 to 9 is -1. 10 to 11, nothing. Or 0, there's no modifier. 12 to 13, +1. 14 to 15, +2. 16 to 17, +3. And then 18 is +4. Okay? So figure out how to get the modifier out of your score. There's some math you can do if you like math. If you just want to do a bunch of if-elses, it's perfectly fine. Right? There's definitely more than one way to do this, and that's okay. You don't have to do the math if you don't want to. If you like the math, go for it. It's a silly math thing. So our function then, get ability modifier, accepts the value for these attributes and returns the correct modifier. Then we're going to write a function menu. It prompts the user to enter an action and returns their choice. They can pick attack, negotiate, search, and eat. Okay? If they choose attack, we're going to, quote, roll a 20-sided die and add the better ability modifier score from strength or dexterity. So whichever one of these is a higher ability modifier, we'll add that to their 20-sided roll, which is just a random number 1 to 20. If the total's greater than or equal to 12, we'll tell them that they hit. Otherwise, we'll tell them they miss. If they hit, roll a 6-sided die, add their ability modifier to calculate the total damage, and display the result. You generate a random number 1 to 6, add their modifier, and said, you did 7 points of damage. Good job. You did 2 points of damage. Good job. This probably shouldn't go below 0. You can't do negative damage. So let me add that note. So don't go below 0 for damage. So if you have negative scores, modifiers for strength and dexterity, because you have really bad rolls, it's possible to do 0 damage, but not negative. Okay? If they choose negotiate, roll the 20-sided die, add their charisma modifier score. If it's greater than or equal to 15, say they negotiated the truce. You don't want to fight this person anymore. We talked them out of it. Sure. If they choose search, roll a 20-sided die, add the better score of intelligence or wisdom. If it's 12 or more, tell them they found treasure. Otherwise, tell them they found nothing. If they find treasure, use a function that returns the name of some random treasure, like gems, gold, jade figurine, other something. I just come up with something. So you have a function like get random treasure that will give you a random treasure name. So it's a function that will call a function here, right? This is function calls a function here. Function tion. There we go. Right? If they choose eat, tell them they ate some rancid food. Roll a 20-sided die, add their constitution ability modifier. If it's greater than or equal to 10, tell them they're able to handle the rancid food without getting sick. Otherwise, tell them they got sick and need to stay in bed. Sure. We'll allow them to choose an action 4 times from the menu, displaying the results each time. So if they want to attack 4 times, they just get to attack 4 times. If they want to do one of each, they do one of each. Sure. So a bunch of different functions here. Okay? These are the minimum required functions. You're welcome to add more. Okay? But the ones that are defined here are the minimum ones that you need. Okay? Like rolling a die, hint, 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 is a really good function. If you tell me how many sides are on the die, I can give you that random number, 1, 2, number of sides. You don't have to. You're not really saving a whole lot because it's just random.randInt, but you can if you want because it puts a nice name to what you're doing. Okay, so in terms of your scoring here, again, when you submit it here, please use the self-assessment. You can't click the rubric. I'm really sorry. I wish you could. I didn't write D2L. It's not my code. You can see it, so just copy paste the text or like tell me, hey, for number 1, I got 2 points. For number 2, I got 2 points, whatever. This one's worth 12 points total, so worth a couple more points than the project 1. So the project will keep increasing in points. So project 3 will be worth more than 12, and project 4 will be worth more than whatever project 3 was. It'll probably be like 15 and then 20. Because with programming, you don't get to forget anything. Right? The things that we learn just build on itself and build on itself. And we will always use if and else's from here on out. I guarantee you there will not be a program you write that doesn't have at least an if or an else. Because otherwise it does the exact same thing every time you run it, which is kind of silly. So they'll increase in points. So your character is given a name with a function, and the name is used in the outputs later. Okay, 2 points for that. So when we output what happens, we use the character's name, right? When we display the results, like Bobbert gets sick. Sure. The ability scores are generated using the sum of 4 6-sided dice, dropping the lowest. 2 points for just working that function out. 2 points for your ability modifier function. Accepts the ability score, returns the correct modifier. Again, so there's a parameter or an argument for a score, 3 to 18, and it returns the correct modifier, -4 up through +4. Right? I think it was -4, right? Yeah, -4 up to +4 is our range here for modifiers, right? Don't worry about the higher things. It's okay. We're only level 1. Points for your menu function. 2 points for that. Gives them the menu, returns the choice. It's not a very interesting function, but it just puts a name to what we're doing. Hey, what do you want to do? And we're going to do this 4 times, so it really is saving us a bit of code here. Right? I don't need to have that same menu 4 times. I can just say menu, or whatever we want to call our function. 2 points for the attack, negotiation, search, and eat options. Letting them do this 4 times, 2 more points. Okay? So, like, there's a decent amount of work here, but not too much here. So it looks like this is the bulk of the work, but it's not. Right? It's all the different functions here. Okay? So, like, attack could be a function if you wanted. It doesn't have to be a function. But it could be. It's up to you. Right? This makes sense? A little crazy. Sorry. I'm nerdy. Okay? Cool. That's it today. So we got the rest of the day for the lab. Get started on the project if you want. If you're fried, just go home. It's cool too. We got all week. So lab 3 due next week, 6 p.m. Project 2 due in 2 weeks, 6 p.m. Okay? Awesome. All right, folks online, if you got anything, hit me up on Discord or send me an email, and I'll see you then.